Thought I would make a short video on my design and build process for what I'm going to be using for to replace the lead acid batteries in my golf cart. This is my first battery, and I'm building 3 more. And so this kind of gives you some technical information about it, and I'll get into what it all means here in just a second. But this is a 48 volt. This single unit is 48 volts, and in total this single unit is just a little over 1.5 kilowatt hours of energy. And so that's the end product right there. And that the form factor is basically the same size in the flat dimensions as the standard golf cart battery, at least in my EasyGo RXV that has 4 12-volt AGM batteries in it right now. And it's a little bit shorter going this way and substantially lighter altogether. And I'll try to talk about that here in a second. But this battery is made from these, what they call 32650 lithium iron phosphate cells. And you can buy these. You need 80 of them for each of the batteries cases. So 80 times 4 if you're going to build them all at once. And then this case here is you can find on the internet pretty easily. eBay is where I get them, and they come basically just empty like this, and on the underside you've got connections for your battery cells on the inside. And even though they don't make this completely clear, the ones that I've purchased come with these 32650 holders. And one thing you have to kind of do is there are 5 this way and 9 this way, and I only need 8, plus I need the extra room. So I just put these in my table saw and cut off the extra row, and then I've got 5 by 8. And I'll show you what that looks like here in just a minute. I also have bought these DC rated breakers, and you can see they're not part of this lid. And I'll jump over to one that I've already made. So here's one that's built like this, and you basically have to cut out a spot for that to go in, and I have it wired up on the positive side. All right, then so that's DC breaker in the basic battery box. And you can buy this nickel strip that's made for spot welding these cells. And then of course, gotta have a BMS. This is a 100 amp BMS made for a 16S lithium iron phosphate chemistry. So then I take the 80 cells and I put them in the 5 by 8 cell holders. So they're 5 this way, all lined up in the same. So you have 5 facing one direction, 5 the other direction. And then you repeat that again. And I'll show you my schematic. I had a couple of different, just kind of working through some possibilities on what I might do, and I finally landed on this configuration. Looking from the top, you see the negative ultimate negative comes out here, and then you circle around, snake back around, and then ultimate positive comes out there, both on the inside. And so this is what it ends up looking like. This one is in the stage of almost being completed. So you can see here's the ultimate negative, and then if you follow this around, it kind of keeps going like this, keeps going, and this is making the series connections. And then there's another pack, and what I will do to connect these together is I will lay this one down and lay that one down, and they'll be face to face, and I'll have a single connection that mates these two. And once they're mated, I'll flip them back up, and then I fold them together. Of course, obviously I'll be putting an insulating layer here, and also on the outside. But when I fold them together, they end up like this. And here you can see the ultimate negative and the ultimate positive. This one goes up to the top of the battery box, and then the ultimate negative from the battery goes over first into the BMS, and then out of the BMS will go into the top of the battery box. And then you can see that folded area where the pieces where I'm going to make this connection and fold it together is actually down in here, and it's insulated from the BMS by this, I don't know if they call it fish paper or battery insulating gasket or whatever. You can find that on eBay or Amazon also. It's got sticky on one side and it's not on the other. And then the BMS is stuck on the side. And then all the balance slot wires are connected to the tabs for each cell group. You can see how that's done as a finished product. But over here, as I make them, so when I'm putting this series connection together, and I cut this this lattice, I save a little leg and fold it over, and so I've got a connection or an access to each of the cell groups as I go, and that makes it really easy to run those wires back over the top from the BMS and just solder them on. And then that all kind of goes together. And then when it's all said and done, I will have 4 of these. And again, they're already 48 volts. So I wouldn't have to put all 4 of them in there. I could put 2 or 3 or 4. Reason why you would want at least 2, probably 3, is just the amperage that you might pull out of it on your golf cart. So anyway, the way I'm going to have it is these 4 put together at 1C will be able to put out 120 amps, which is nothing, to operate a lithium iron phosphate at 1C, because they are capable of a 3C continuous discharge, which means that as a group of 4, this pack will be capable of discharging 360 amps continuous at a nominal 51.2 volts. Of course, that changes depending upon load and so forth. But I think that this setup, when I'm done, will allow for my golf cart to probably have a range well in excess of 40 miles, maybe as much as 60 miles. Of course, all that depends on weather and how you drive it. So that's just a quick video. Oh, I'll show you a few other things. I bought some, this is going to be my bus bar that will connect all 4 of those batteries at 48 volts. And then I've also got, let's see what I got here. This is a 48 volt to 12 volt DC to DC converter that's capable of 360 watts. So I'll take my 48 volts and convert that down to 12 volts for my accessories like my horn and my lights and blinkers and stuff like that. And then in this box here, I've got a 12 volt DC distribution block. So again, 48 volts will go into this box, 12 volts will come out, and that 12 volts will go into this distribution block, and then I'll be able to connect anything that I need that needs to have just 12 volts into this distribution block. And like I said, to finish up, each one of these batteries, while not insignificant in its weight, beats out the same by about 50 pounds. So I think this weighs somewhere close to 20 pounds. And a single AGM battery that's in my golf cart, I believe weighs somewhere in the range of 70 pounds or more. So for each of these, that'll be a total weight savings of 200 pounds. And I'll have greater usable amp hours across the board. So should be a very significant upgrade. All right, that's it.